So I'm starting a new approach, a new series. Um, in self-reflection, I realized that trying to force myself to be creative over various number of topics was not sustainable to me, and at the same time, I felt like I was behind on reading a lot of books, absorbing content, refining my knowledge of things. In light of what happened recently to me, I realized that I needed to really start from scratch. I already know a good chunk of systems thinking, and part of the principles which allowed me to grow exponentially in a variety of things, not just one thing, and has helped me as a compass, directing me in various ways of originality and ultimately innovation. So to restart my awareness, my knowledge, my education, it always helps to see what new angles, new perspectives, how do you look at systems thinking in a way that helps others understand things. So with that said, I'm going to start on Systems 1, 4th edition, Introduction to Systems Thinking. So come with me on a journey, and let's dive into where this will lead to. This channel is first and foremost systems thinking oriented. It just so happens that user experience layers on top of that, and that is my profession predominantly. As of this point, I don't know if that's really going to be my thing still. It could be a part of my career, but I'd like to see systems thinking applied on a broader scale, not just with regards to digital design. I read the first chapter of Intro to Systems Thinking by Kauffman and Kauffman, Draper Kauffman and Morgan Kauffman. And I wanted to share some major points that came out of the first chapter. The first chapter is called, let's see, beyond the foreword, it's called What is a System? I took a number of notes in this new notebook, which I got from Daiso, which is a Japanese kind of, it's like the Japanese equivalent of a Big Lots mini store with a lot of stationery, a lot of random tchotchkes and tools that are very helpful from a day-to-day basis. And the reason why I got Japanese paper is because it is one of the best, if not considered the best type of paper for those who use fountain pen ink. Now, what you see here is a ballpoint pen, but I had to buy this from Japan also. I had to import this. This is a ballpoint pen. If you check my Instagram, you'll see it. This is a ballpoint pen that uses fountain pen ink. There is another company that also has a ballpoint pen that uses fountain pen ink, but right now I don't write in with a standard fountain pen because there's something about it where I don't feel it gives me enough freedom when I write, because it has a nib that goes in a particular direction. And while it is great for cursive writing, I could write cursive just fine with a ballpoint pen orientation. So for this video, I wanted to share with you some key points from the first chapter of what is a system. Some contributions of general systems theory, which is the understanding of systems thinking, where it tackles large and messy real-world problems that don't easily fit in one specialty. Because what ends up happening in society, especially in Western society, is that we really specialize in one thing. That's why you have your master's. That's why you have your doctorate, and you really push in to when on your dissertation, you've punched in so hard into that one specialty that you've broken the limit of what is perceived, and now you've introduced a new thought, even if it's just another inch or two more, because of the rigors of scientific papers and study and research. But what's nice about general systems theory and systems thinking overall is that you look at things from a multifaceted point of view. You don't just lean on one discipline. It's very similar to cognitive science, where it leans on various different angles that cognitive science contributes to. Like it can contribute to artificial intelligence as much as anthropology, human behavior, right? And systems theory is that understanding where it can apply to various different perspectives, but ultimately it kind of unifies and contributes from one discipline to another. And it also provides a way for non-specialists to get a better, clearer picture of how things work without spending all their life in the details of every subject. And it's funny because this goes with the axiom or the saying. It's jack of all trades, master of none, but better than just being a master of one. And when I was younger, I wanted to be. I admired the Renaissance man, right? The individual who has an awareness and a practice of various different disciplines, whether it's botany, chemistry, engineering. Like this is the type of person that you would see that could build a town, that could survive in the jungle and build a treehouse. That sort of idealism. And I just so happened that over my life, I started doing that. I started having a variety of interests. I started learning a little bit of botany. It helped me take care of house plants. It even helped me learn how to manage a bonsai plant, which can be a challenge depending on the plant or tree. And this multifaceted, multidisciplinary approach really enriched me as a human being. And I didn't realize what was happening. I just had an interest. I pursued it. I did it. Showed people I was doing this. And I only learned later from just feedback from people of how amazed they are with the variety of things that I can do. And I never really intimate those compliments because in reflection, there's a part of me that still feels that vulnerability, that sense of worthlessness. And so I mask that internal narrative, that struggle, by just constantly doing more things or just having the joy of exploration and learning and doing and helping. It doesn't mean I'm just a no resistance, boundaryless, helper. I do have boundaries now, but for a while, I always applied what I knew. I always put actions to the knowledge that I had. So going back into it, a system is composed of interconnected parts, while a pile of stuff, is an assortment of non-connected parts. This was something that is different from what I learned before in a different systems thinking book, a much older systems thinking book that I don't think had a later edition. The distinction of a heap, because when I learned what a system was, it was just, I knew that there were interconnected parts, but I didn't have a contrast to that. I didn't have a definition or word to describe broken, non-interconnected parts, basically disconnected parts. And so when they introduced in this book the notion of a heap, that was a great way to triangulate what a system is, because a system is interconnected and a heap is not connected. The way they exemplify it is, it's like a pile of Legos versus the classic mousetrap game, where once you trigger one thing, it starts the full sequence of everything else. System functions as a whole. Its behavior depends on its entire structure and not just an adding up of the behavior of its different pieces. Now, here's something that's important about this. There was a phrase that I struggled with when it came to systems thinking. It's the phrase, the sum of its parts. And it boggled my mind what exactly that meant, the sum of its parts. And through this chapter, through this way of introducing the topic, I had a better understanding that the sum of its parts means that the ultimate conclusion of what all these parts add up to is what defines it. There's another thing that, and I could be wrong about the sum of its parts, so please correct me in the comments if that is the incorrect understanding. It's such a simple phrase, but for some reason my brain just cannot latch on to that. There another point that came in the chapter was the difference between a tightly coupled system and a loosely coupled system. And the way they distinguish that is a tightly coupled system cannot be divided to its essential parts or it loses its nature. For instance, a cow, I'm sorry to you vegetarians and vegans, but basically, if a cow, you cut it apart into its various pieces of meat, it can no longer function. It no longer operates as a cow, right? Because now it's just pieces of meat. And so its nature is completely destroyed. Um, and a loosely coupled system are basically like organizations, right? The way people kind of come together, they're loose because they don't fully rely on each other. They can easily come apart. They can come together, but it's still a system because they can interface with each other. But it's not like a tightly coupled system where it's heavily dependent on each other in order to exist. And because systems are always going to be a part of other systems, when a primary system, let's say for instance, the human body, we have subsystems. For example, the human body as a whole has multiple subsystems. You have the respiratory system, you have the circulatory system, and the nervous system. All of these things do influence each other, but there is a primary function that the subsystem serves, which contributes to the overall major system above it, the parent system, which is the entirety of the human body. And system sizes can be broken down into smaller subsystems all the way down to atoms and particles, because technically you can keep creating derivatives of each system until it hits the subatomic level. And then a collection of smaller units is more stable than one large unit. This is actually fascinating to me. This is an angle that I didn't consider. I've always intuited that this was a thing, but it's great to get that validation that smaller, tightly knit squads will always move faster and become more stable than larger organizations. And that's why you'll always see, like let's say, for instance, in a working organization, you'll have sub-departments and teams that will split up to tackle an issue. Teams that are responsible for moving something forward versus the cumbersome activity of having a bunch of things validated and checked and all that stuff. Like, sure, that is important, but at the same time, it slows the entire process down. So if you want to move fast, move smaller or move slower, or sometimes just do it yourself versus being a part of a group and a larger group. That'll slow everything down. It's one of the challenges I've had, especially when I've been managing this foodie group out here in Vegas that I conducted last year. It was really fun, but it easily got out of hand because a lot of the places that I wanted to go to, they really only allowed 4 people max. So if the group got bigger than 4 people, they would have to sit at another table, or it just would be very difficult. So I couldn't invite more than any more than 4 confirmed people at any one time, and that made it very difficult, right? You have to accept the level of responsibility when you try to scale it bigger, because waste and fallout and consequences are higher, and that's something I keep in mind when I organize events. But absolutely, smaller organizations, smaller systems are oftentimes more efficient than more complex, larger systems. The way they exemplified this is protons and neutrons are the largest subatomic particle in nature. Physicists tried to make bigger particles, but they didn't really last long, like maybe a couple nanoseconds or microseconds. A living cell beyond a certain size would die from suffocation, so the largest one-celled organism will basically suffocate if it gets too big. Similar principles limit animal sizes like dinosaurs and whales. So atmospheric conditions and resource conditions at the time when the dinosaurs were alive were different. They were able to grow a much larger size. You can't really do that anymore. That's why a lot of the animals have a cap in terms of sizes. And, you know, if cryptozoology is really functional, then there's cryptids who will grow a certain size because they don't really have any competition. But that remains to be seen. And in social organizations, a small group works more effectively than a large group, which I mentioned earlier. I even did a small diagram right here, exemplifying large organizations versus small interconnected smaller groups, and how this one is better, even if this is possible. Something to keep in mind when it comes to systems thinking on an organizational level, which I am also very curious and like to study as well. System maintains internal stability through an interconnected circular interaction of loops and flows. A great example that was in this book in the first chapter was a bike rider's actions have an influence on what a bicycle does, and the behavior of the bicycle has an influence on the rider's actions. Without the constant dynamic between the rider and the bike, it would be inert or unstable. And there is a kind of example that they have here. I don't know if you can see it, but it's basically you first put an input. So with any feedback loop, you have an input, and then for the sake of the bike example, you have the brain processing the input, the muscles carrying forward the instructions from the brain, and then the muscles engaging the bicycle, and then from the bicycle, it creates an output. And from that feedback loop, it starts back in the input again. So it does this constant loop in order to keep the bike rider and the bicycle going in its own interdependent system. And I even wrote a note here because from my studies in biology, and something that I've always kept in mind is that the healthcare version of this is homeostasis, because your biology, your body maintains a constant level, like your heart rate is a constant level, your blood flow, etc. Your breathing goes at a certain level, and then your entire body in the various different subsystems will try to keep in balance with each other. That's why when you have high blood pressure, it affects so many other systems. If you have like acidosis, the increased acidity in your blood will start affecting your breathing. It starts to affect your neurological function. So homeostasis is the systemic balance, the constant balance loop that your body maintains. And that was the last point that was made in this first chapter. Beyond that, thank you for watching. I'll get to chapter 2 as soon as I can, and let's see where further education on systems thinking, and I have other books that I like to cover, but let's go chapter by chapter. And if you don't want to watch it, just listen to it on the side or wherever. So with that said, I'll talk to you later.